On this set of problems, we're going to work on balancing equations. So one of the ways you can do it is a little chart where you keep up with the atoms from each side. I'm not going to do that because it's time consuming. Now, there are a couple things that I want you to remember when you balance is do hydrogen and oxygen last in that order. The other thing I like to do when balancing is work one element at a time left to right. So for example, I'm going to work on aluminum here. I've got 2 aluminums on the reactant side, so I need 2 aluminums on the product side. In order to achieve that, I've got a 2 there. So we've done the aluminum. There's no other aluminum, so I've got a little dot underneath it. I'm going to skip my oxygen. I'm going to move to chlorine. Okay. I've got 2 chlorines on this side. I've got 6 on this side. Because remember, this is like when you have 2x plus 2. That means that you distribute to both terms, so you end up with 4x plus 4. So in this case, you have 2 aluminums, but you have 6 chlorines. If that's the case, then we need 6 over here. So in order to achieve 6, we multiply it by 3. So we've got 6 chlorines here and 6 chlorines here. We had 2 aluminums over there. Then we've done our chlorines, so we'll skip to the carbons. We've got 1 carbon on this side, on the reactant side, 1 carbon on the product, so we're done, at least we appear to be. Let's go back and do our oxygen. We have 3 oxygens on this side, so we're going to need 3 oxygens over here. Well, when we change the carbon monoxide, we've not only changed the oxygens, we've changed the carbons as well. So let's go back and clean up our mess. So we have 3 carbons, 3 carbons, 3 oxygens, etc. So we now have a balanced equation. Okay, now when I go to work the next one, I'm not going to keep up with the numbers on the bottom like I did before. I'm just going to follow through my species. So I've got phosphorus on this side. It is not in the same form on this side, so we're going to treat it accordingly. I have 1 phosphorus, 1 phosphorus. I'm done. The phosphorus is fine. I have 5 chlorines on this side, so I'm going to need 5 chlorines on this side. We're back to the hydrogens. I've got 2 hydrogens here, but on this side I have 3 hydrogens here and 5 hydrogens there, which is 8 hydrogens. Okay, so if I need 8 hydrogens, I'm going to put a 4 here. That gives me 8 hydrogens here, 8 hydrogens here. Now let's double check the oxygens. I have 4 oxygens here, I have 4 oxygens here. I'm now balanced. Okay. The next one is phosphoric acid with zinc hydroxide, and if you'll notice, this is the phosphate ion and this is the phosphate ion. So if we want to leave it alone and not separate it out, we can't double count the oxygens, and we only count the phosphoruses with the ions. So what we'll do is we'll see that this has 2 phosphate ions, so I'm going to need a 2 here. Okay. Now, that takes care of our phosphates, our zincs. Wait, I've got 1 zinc on the reactant side. I got 3 zincs on the product side, so I'm going to need 3 there. That takes care of everything that's not hydrogen and oxygen. So let's go back and look. We have 6 hydrogens here. We have 6 hydrogens here. 6 plus 6 is 12, or 6 times 2 is 12. So that will give us a total of 12 hydrogens on the reactant side, 12 hydrogens on the product side. And let's count our oxygens. Remember, we've already counted that as a phosphate, so it doesn't count. We've got 3 times 2, which is 6. So we have 6 oxygens here, 6 oxygens here. We're done. Remember, when you use a polyatomic that doesn't change, don't double count it. Okay, do not double count the species involved. Double count species. And that's usually more of a problem with the oxygen than anything else. Now, we come down to the last one. We've got calcium silicate plus hydrofluoric acid, etc., and we produce it here. Okay, so let's look at the calcium. We've got one calcium here, so we're done. We've got one silicon here, one silicon there. We're going to skip the oxygen, we're going to skip the hydrogen, so let's look at the fluorine. So we've got one fluorine on the reactant side, but wait a minute, we've got fluoride here, we've got 4 of them here, we've got 2 of them here, so we have a total of 6. So let's try a 6. If they're even numbers, it usually will work its way out. The only problem is when they're odd, one of them has to go even. So now that we've got our fluorines balanced, we didn't affect our calcium or our silicon, but we did affect the hydrogen, which we haven't balanced. So we have 6 hydrogens here, which means in order to get 6 here, we're going to need a 3. That leaves us with 3 oxygens on the reactant side and 3 oxygens on the product side. So we have evened out. So we've balanced these equations using the rule of hydrogen and oxygen last, and if they're polyatomics, we treat them as an entity.